The Galileo spacecraft, looping the Moon and Earth. An orbital slingshot to pick up speed for a mission to Jupiter. A detour with a bonus. En route, Galileo had captured the first pictures of Earth in rotation. The date, December 1990. The sun's reflection skims across the Pacific towards Australia. Our blue Earth, third planet from the sun. At a distance of 150 million kilometers, neither too hot nor too cold. The ideal incubator for life. These are satellite pictures, a compilation of thousands of cloudless images which show Earth as never before. Now we see the upper atmosphere, the aerosols of the ozone layer. Here in motion, it's this filter that protects us from solar radiation. During 2,000 million years, plants have changed our atmosphere by breathing oxygen into it. Today, CFC emissions may be changing things again, starting with this hole in the ozone at the South Pole. Earth has a busy atmosphere, 21% oxygen, 78% nitrogen. Without it, there'd be no life. And yet we threaten it by burning fossil fuels and forests. Each year we spew 7 billion tons of carbon dioxide into the air. We are gambling with immense natural forces. The energy in one day of a hurricane would power all industry in the United States for a year. We're at the mercy of our atmosphere. Weather satellites help us understand the atmosphere, the life-sustaining engine that maintains a mean global temperature of 15 degrees Celsius. The wind systems are driven by hot air rising at the equator. Their direction is modified by the spin of the Earth. Carbon dioxide keeps the planet warm by trapping heat. Scientists say we're producing too much carbon dioxide. They worry that it'll cause overheating, threatening a lifeless inferno like Venus. The rotation of Earth means that sunlight falls on only half the planet at any one time. From the surface, the sun appears to move from east to west across the sky. In fact, the sun is still. It's our planet that's moving, a 24-hour rotation causing day and night. This time-lapse through the night has the moon, top left, sinking in the west. And here, the Milky Way and the stars seem to travel through the heavens. Again, it's not the stars that are moving, it's Earth rotating on its axis. Were the axis upright, day and night would be the same the world over, but it's not. Earth is tilted 23.5 degrees from vertical. This varies the length of day and night. Add to that the complication of Earth orbiting the sun, and there emerges an explanation of the 4 seasons. It takes Earth a year to orbit the sun. Each day, the angle at which sunlight falls on Earth changes slightly. Over a season, it's quite a lot. In the 6 months from winter to summer, the change is greatest of all. From this position, it's summer in the northern hemisphere. The north has short nights and long days. The equator hardly changes. The south has long nights and short days. From this opposing position, it's winter in the northern hemisphere, short days and long nights in the north, long summer days and short nights in the south. From Earth, this means the midwinter sun is low in the sky. At midsummer on the same latitude, it's higher. This satellite sequence shows another seasonal change, the northerly advance of vegetation growth as the northern hemisphere tilts towards the sun. In Antarctica, the seasonal ebb and flow of the ice cap. Summer, and now the return of winter. Ten 10,000 years ago, the northern ice cap reached as far south as New York and London. It's uncertain, but such ice ages could be caused by a periodic wobble in Earth's orbit. Satellites monitor global temperature. Currently, we're enjoying an interglacial period. Temperatures are steady, although over the last 100 years, they've risen by 0.9 of a degree Celsius. "71% of Earth is ocean. The rest began as a supercontinent 250 million years ago. Ever since, its component parts have been drifting on plates towards the positions they occupy today. The red dots are volcanoes. They mark cracks where the plates meet, like pieces of a jigsaw. Even now, at a few centimeters a year, the drifting continues. Under the oceans, the plates are either pulling apart or pushing beneath one another. This lava lake is like plates parting, and this like plates subducting. Where plates interact, volcanoes erupt. This is the Mount St. Helens volcano, on the line between the Pacific and the North American plates. A visible reminder of Earth's volatile interior. From above the clouds, the plume of the Mount Pinatubo eruption in the Philippines. Stratospheric pollution that reduced Earth's temperature by 1 degree as volcanic ash girdled the globe. Before Pinatubo, a sunset with stars. Afterwards, a red atmospheric haze. These are the lights of Western Europe, another pollutant that obscures the stars. How clearly we'll see the cosmos in the future depends more on the human factor than occasional volcanic eruptions.